All right, so now I have a fun one for you. We're going to talk about signals. We're going to talk about communicating with our process from within our process or from the outside world. So we're going to talk about signals. Signals are handled by your operating system. You might be used to like sig_term or kill-9, which is sig_kill. You can't trap that signal, but there are other signals you can trap, and we're going to talk about that. So these are provided by your operating system, and we're going to show you how to, I'm going to show you how to trap them and how to respond to them in your bash code, which is pretty cool. So before we even jump in here, we're going to be using the trap built into bash, so you can do help trap on it and you can see it. There's a whole bunch of options here. One of the things I like is trap -L. This lists all of the signals that you can respond to. So these are the signals that your operating system makes available to bash, and we can trap any of these. SIGINT, this is the interrupt signal. This is what is sent when I hit Control-C. SIGINT is what is sent when I do that. SIGWINCH, this is sent if your terminal is resized. SIGINFO is only available on certain operating systems. With my shell, because I'm on macOS, I can give a Control-T and it will print a SIGINFO. There's no process running, so I'm just getting a little bell warning up here. Yeah, there's all sorts of fun signals. So let's go ahead and look at what we have here. So we have our simple exit script right here. So what we do is we define a function called cleanup, and then we echo cleanup function running. Okay, very simple. Then we trap cleanup to exit. So the way trap works is here's the code you want to run. So I just gave it a simple function name, and here are the signals you want to trap. You can give it multiple signals. I just gave it exit. Exit is a special like pseudo signal, which basically hooks it up to the @exit caller. This means before bash quits, before this script is done, it will always run this code, which is super nice. Put a little asterisk next to always. You could technically kill -9 and then it wouldn't have a chance to run this because you can't trap it. But this is your best effort at trying to run something at the end of the script. So we're going to print script starting, ... script done, and then we have that cleanup function. So let's go ahead and look at that source code. Let's run this, and we can see script starting, ... script done, and then cleanup function running. So this ran at the very end because we trapped it to the exit signal. So that's pretty cool. Here's a really cool way to sort of like defer cleanup. If you make like a temporary file or something like that, you can put that in your cleanup function to remove that file or whatever you need to do. The next one here is we need to talk about codes. So take a look at this. Script starting, ... script done, and then we exit manually with the code 1. Now notice the cleanup function will run, and cleanup doesn't have exit in it at all. So what's going to happen when we run this? Let's go ahead and run our code here, and we echo $?, and that's the nice thing. The code that we exit here is retained. So whatever runs here doesn't really matter. We're still going to exit with that same code unless we override it. So let's talk about this next one, which is called exit override. Hey, look at that naming. I'm awesome. So we have the cleanup function that exits 2 here. That's the only addition to the script. We're going to exit 1 at the bottom. We're going to exit 2 at the top. Let's go ahead and quit out of this, pull up that source code, run it, and we can see that the cleanup function is running. That's all well and good. Let's print the exit status, and look at this. We get 2. So you can override it in the cleanup function. I don't really mess with this myself. I don't worry too much about it, but this is just good to know, good to be aware of that this is a thing that can happen. All right, so let's talk about this next one. This one's called trap debug. This is really cool. This is another bash internal thing. This isn't really a signal sent from your operating system, but you can trap something called debug in bash and have it run myfunc. So myfunc up here just prints debug running, and then there's a variable called bash_command. So let's go ahead and run this and see what happens. Look at that, debug running, echo script starting, debug running this, debug running that, debug running that. It's very similar. If you remember bash -x, we could run that and we can get the sort of debug output. So you can actually trap that signal and run code as a response to it, which is kind of cool because it's a little bit more advanced than bash -x because I'm running code here. I could do some work. I could format data. I could grab something off the file system. Probably don't want to do something too heavyweight here, but you could. The option's there. And last but not least, I want to show this because we can trap SIGINFO. Now here's the thing about SIGINFO. I mentioned it, it's on my system, but some operating systems don't have SIGINFO. Like I don't think Linux has SIGINFO, so you can do error checking. Trap will return a failure if it's not there. So on this program, this is only going to work if my system supports SIGINFO. Otherwise, it's just going to stop the script. But if it does work, we're going to go into an infinite while loop where we sleep for 1 second and we print the word running. So if we go ahead and do this, we go into an infinite while loop, we print the word running. I'm going to hit Control-T. And we'll get some debug output about what's going on, but look at this. It printed hello world. So we can actually trap that signal. Now, of course, we don't have to trap SIGINFO if we didn't want to. We could trap SIGINT, and this is the interrupt signal. So now, when I hit Control C to stop this, it doesn't stop. So what do I do now, huh? Ready for this? We're going to Control Z it, which puts it in the background. Now it's in the background, but it's paused. It's not running. If we wanted to start running, we could type BG and hit enter, and then it starts running the process. I can't actually talk to it. That's super annoying. So I'm going to type an FG to bring it back to the foreground, hit enter. Now it's running in the foreground. Control C, I still can't stop it, so we're going to kill it. Control Z stops it. It's not running. I can run jobs to see all of my currently running jobs, and I have job 1 here. So let's go ahead and kill %1. There we go. So now that process is dead. It has been terminated. Terminated with signal 15, which is sigterm, the default kill signal. So that's what happened here. That's how we broke out of it. So yeah, backgrounding jobs is super convenient. When you have anything running on the shell, you could do like sleep 60. I can Control Z that. It stopped it. It paused it. It sent it a SIG-T stop signal. And now I can either make it run in the background with BG, or I could bring it to the foreground with FG, or I could kill it with %%, which is % is just the last process that was put in the background. So that's how that worked.